Imagine gazing out into the vastness of our galaxy, stars glittering like distant beacons across an infinite ocean of darkness. For centuries, humanity has looked to the heavens and dreamed of crossing that cosmic sea, of reaching not just the closest stars, but entire galaxies far beyond our own. Yet, as our understanding of physics deepened, we encountered a daunting reality. The speed of light is a universal speed limit. Even the fastest spacecraft we can imagine would take tens of thousands of years to reach the nearest stars. So, is there any hope for interstellar travel within a human lifetime? Could there be hidden shortcuts in the fabric of the universe, waiting for us to discover and unlock them? Today, let's journey into two of the most fascinating and speculative concepts from theoretical physics: the Krasnikov Tube and extraspatial dimensions, sometimes known as hyperspace. These ideas, though rooted in mathematical theory, dare to challenge our notions of space, time, and what might truly be possible in the quest to explore the stars. To decode this problem, watch until the end. A surprise awaits you. Subscribe to the channel now so you don't miss out on valuable knowledge, and join me on the journey of independent scientists. First, let's tackle the problem. How do we traverse the enormous distances between stars if nothing can move faster than light? Traditional rocket propulsion is simply too slow, and even the most advanced concepts like ion drives or nuclear fusion would only shave centuries off the journey. That's where ideas like the warp drive come in, a concept that bends space itself, allowing a ship to ride a wave through the cosmos, ostensibly without violating the speed of light within its own local space. But there's a lesser-known, equally mind-bending alternative: the Krasnikov Tube. Conceived by Russian physicist Sergey Krasnikov in the 1990s, this concept takes a different approach to warping space-time. Instead of creating a moving bubble around a ship, imagine constructing a permanent tunnel, a fixed corridor through space-time itself. Picture it as a kind of cosmic highway, a shortcut that's already been carved out and remains accessible for future journeys. Here's how it would work in theory. A starship travels from Earth to a distant star at sublight speeds, leaving behind a lasting distortion in space-time along its path. This distortion forms a tube, a Krasnikov tube, essentially a tunnel through which subsequent travelers can move at effective speeds exceeding that of light relative to the outside universe. Inside this tube, the geometry of space-time is tweaked so that a return trip, or journeys by other ships, can be accomplished far more rapidly than the initial voyage. It's an elegant idea, but like all such theoretical constructs, it faces immense challenges. The creation and maintenance of a Krasnikov tube would require an exotic form of matter, something with negative energy density, often dubbed exotic matter. In simple terms, this is a type of substance that behaves in ways entirely unlike any matter we've ever observed. It would need to exert repulsive gravitational effects, essentially propping open the tunnel against the tendency of space-time to snap back to its normal configuration. So far, negative energy remains a mathematical curiosity, glimpsed only in fleeting quantum effects, and far from being harnessed in any practical way. There's another, even thornier issue: causality. Some versions of the Krasnikov tube could, in principle, allow for time travel or the transmission of information into the past, which would wreak havoc with cause and effect. These paradoxes threaten to undermine the very foundations of physics as we understand them, and suggest that there may be deeper principles at work in the universe that prevent such shortcuts from ever being realized. If the Krasnikov tube is a speculative shortcut through our familiar space-time, what about the possibility that entirely new dimensions might offer even more radical routes? That brings us to the concept of extraspatial dimensions, sometimes referred to as hyperspace. We are intuitively familiar with three dimensions: length, width, and height, plus the dimension of time. But what if our universe is actually embedded in a reality with additional, hidden dimensions? Theoretical frameworks like string theory propose that there could be many more spatial dimensions, curled up so tightly that we never perceive them directly. However, if these dimensions exist, they could offer extraordinary possibilities. Imagine our universe as a two-dimensional sheet of paper. 2 points on opposite edges of the sheet are separated by a long stretch across the surface. But if you fold the paper, those points can touch, making a shortcut through a third dimension. In the same way, if there are additional spatial dimensions, it might be possible to fold or tunnel through them, drastically reducing the apparent distance between distant points in our three-dimensional space. This is the essence of the hyperspace concept, finding a way to step off our normal spatial sheet and cut across higher dimensions, arriving at a distant destination almost instantaneously. It's an idea that has inspired generations of science fiction writers, but also provokes serious inquiry among physicists searching for a unified theory of reality. However, just like the Krasnikov Tube, the idea of traveling through extra dimensions faces formidable obstacles. First and foremost, there is no experimental evidence that these accessible large dimensions exist. While some theories hint at their presence, all attempts to detect them, whether through high-energy particle collisions or gravitational experiments, have so far come up empty. Even if such dimensions are real, engineering a way to enter, navigate, and return from them would require technology and understanding far beyond anything we currently possess. So, where does this leave us? Both the Krasnikov Tube and the notion of hyperspace travel represent tantalizing glimpses into what the future of interstellar exploration might hold. They are rooted in the mathematics of modern physics, but remain unproven and, for now, beyond our technological reach. Their study, however, is far from a pointless exercise. Throughout history, ideas that once seemed fantastical, flight, electricity, even the internet, have become reality through persistence, imagination, and scientific progress. By daring to ask the wild questions, by stretching the boundaries of theory, scientists keep alive the hope that one day we might crack the code of the cosmos. Perhaps the universe contains hidden doors, and perhaps, just perhaps, one day we will find the keys. What do you think about the Krasnikov Tube and the possibility of higher dimensions? Are these just science fiction dreams, or could they be stepping stones to our interstellar future? The quest for the stars continues, and with every new theory, we edge a little closer to unlocking the mysteries of the universe. Stay curious, keep dreaming, and never stop exploring. If you've watched this far, congratulations! You are truly a passionate scientific explorer, always persisting and conquering every challenge. Let's subscribe to the channel so we can keep on discovering together.